Hi everyone, this short video will be explaining Kirchhoff's voltage law, or KVL for short, which is one of the most fundamental principles used in electrical circuit analysis. KVL helps us understand how voltage behaves around a closed circuit loop, and it's based on the simple idea of energy conservation. In any loop, energy supplied by sources must equal the energy used by its components. Kirchhoff's voltage law states that the algebraic sum of all voltages around a closed loop is equal to zero, which means if you start at one point in a loop and move all the way around, adding voltage rises and subtracting voltage drops. By the time you return to the starting point, the total will be zero, which is mathematically written as the sum of all voltages equals zero. Positive voltages represent rises like a battery, and negative voltages represent drops like resistors or loads. Let's look at a simple example shown here, which we have a 10-volt battery connected in series with two resistors. One resistor is 4 ohms and the other is 6. Therefore, the total resistance is 10 ohms, so the current is 1 ampere. Using Ohm's law, voltage across R1 is equal to the current times the resistance of R1, which is 4 volts. And then for R2, the voltage across it is 6 volts, which means when we move around the loop, we have plus 10 volts initially, then minus 4 volts from R1, and then minus 6 volts from R2, which is equal to 0 and perfectly satisfies KVL. KVL isn't just theory, it's used everywhere in real engineering systems. For example, in electric vehicles, engineers use KVL to analyze the battery and motor control circuits. Each battery cell contributes a small voltage rise, and as current flows through controllers, sensors, and motors, those voltages drop. By applying KVL, they can confirm that the total voltage drop around the system equals the total battery supply, ensuring the powertrain runs efficiently and safely. The same principle applies in power grids, solar systems, and even small circuit boards inside of your phone. Every loop must satisfy Kirchhoff's voltage law. Kirchhoff's voltage law is based on the law of conservation of energy, and it tells us that the sum of voltage rises and drops in any closed loop is always zero. This law forms the foundation of circuit analysis, and without it, we couldn't predict how energy moves through even the simplest of systems. Whether you're designing an EV battery, analyzing a power network, or building a basic LED circuit, KVL keeps everything balanced and consistent. It's a simple rule, but it powers the logic behind every electrical design we use today. Thank you.